So yes, indeed, in 2001 to 2004, I was working at the University of Aberdeen as a museum manager and knowledge technologist. I got my PhD from Zurich in industrial engineering, so that's studied how to run a factory, and sort of keeps coming back, this idea of manufacturing. Thank you for having me tonight. It's a very interesting coincidence that a couple of weeks ago I was asked to contribute to a book called Framing the Economy of the Future, which is supposed to come out in a couple of years. And I've been asked to write a chapter on the self-production economy. So I'm sort of using this evening tonight as a sort of first rehearsal of my thoughts on this. So thank you again for giving me that opportunity as well. In my talk, I'll first start to trying to explain what I intend when I talk about the manufacturing revolution, then go into what is commonly known as the maker movement, which is this idea of self-production. I have a few slides on the socioeconomic context, but I won't probably go in all the depth there because we've only got like an hour tonight. I'll spend quite a bit of time on explaining or detailing a few cases of self-production and this idea of manufacturing revolution we're pursuing there. I did a study on value creation for business models, of which I'm going to show you a few of the results. And at the end, I'll ask myself and us, is there something like a self-production economy? Do we make this all? So, the manufacturing revolution. We're rather used to talk about industrial revolutions. And I would want to start with sort of going back to this idea of the industrial revolution. And we all know these pictures, very famous picture of Manchester. That's used in all applications on the industrial revolution. So I spent a few hours last night to find an equivalent image on Aberdeen, and indeed, eventually I did find one. So it's not exactly a view that we would all recognize. These chimneys have disappeared. This one, I believe, was demolished in 1908. But the interesting bit in this picture and the picture before is that it combines this idyllic landscape in the foreground with the sort of not exactly beauty of the first industrial revolution. When I talk about industrial revolution or industrial revolutions, I usually refer to a man called Jeremy Rifkin. You might have heard of him, an economist who's consulting all over the planet, which has had him a few years ago in Rotterdam, actually looking at the economic development of the greater Rotterdam area, Rotterdam, The Hague, metropolitan region, to sort of develop a roadmap for the next economy. So his theory is that we actually are living in a third industrial revolution. Because he says every time we got something happening in communication or communication technology and something happening in energy, then we're experiencing the industrial revolution. So according to Jeremy Rifkin, the first industrial revolution in the 19th century happened when the automatic printing press allowed us to distribute news in a different way, when steam power technology came along to actually build power factories. Similar thing, he argues, happened in the 20th century with electrical communication. Think of radio, think of telephone, think of television. And, of course, the oil-powered combustion engine. And then, Germany argues, we're living in the third industrial revolution because we've got this internet as a new communication technology, and we've got renewable energies as a new different source of energy. And he's arguing that the first two industrial revolutions were built on central infrastructures and hierarchical governance, and that, you know, I think the press, there's a central place where the newspaper actually is composed and printed. Radio and television are broadcast from one central point. But internet technology, he argues, is much more distributed, and renewable energies have or are best used in a distributed way as well. So he's going, the first and the second industrial revolutions were sort of vertical, hierarchical. The third industrial revolution is horizontal, or as he calls it, lateral. When we think about those three revolutions, certainly the energy sources. Another thing first. In Germany, they're talking about Industry 4.0, so they're having their fourth industrial revolution in Germany. Because in essence, they're splitting up the second industrial revolution in a more sort of mechanical and more sort of computer controlled. So then it's the fourth industrial revolution. Peter Marsh of the Financial Times talks about the fifth industrial revolutions. So whatever the numbers, maybe some other person could come up and tell us that maybe the seventh industrial revolution. Who knows? I'm sticking to the three industrial revolutions. These are sort of the fuels of those industrial revolutions: coal, oil, and bio-based. You could also think about what are the signature machines of those revolutions. The signature machine of the first industrial revolution is obviously steam engine. The signature machine of the second industrial revolution would be the conveyor belt. And the signature machine of the third industrial revolution, and I will come back to that, is the 3D printing. You could also speculate about the signature role in those industrial revolutions. And the signature role in the first industrial revolution would be the capitalist. According to me, the signature role in the second industrial revolution would be the management consultant. And in line with my talk tonight, the signature role in the third industrial revolution is the maker. So what is that? The maker movement. I'll bring you a person called Dale Doherty. Dale Doherty used to work for O'Reilly before setting up his own media outlet, which is called Make. There's a Make magazine, there are Maker fairs, you might have heard of that. And he is, of course, an evangelist of the Maker movement. So take what he's going to say with a pinch of salt. Also enjoy the way he's really telling the gospel of making, because he starts saying, I'm going to have a pretty simple idea that I'm just going to tell you over and over until I get you to believe it. So there's something strangely religious about it. So this is kind of interesting, this idea that makers want to make, but don't know why. If we look at time, something interesting happened. First, copy of Make magazine came out, and this book, Fab, The Next Revolution on Your Desktop, came out both in 2005. Now we've heard Dale Dougherty of Make talk about his vision of the Make movement. The other party here is a person called Gershenfeld, who's a professor at MIT, at the Center for Bits and Atoms. And his idea or theory or the thing he wants to research is how could we program matter as we can program bits at the moment. So I'll bring you a short sequence of Neil Gershenfeld. This again is an extract from a TED Talk. So in this sequence we've seen two things coming back. One is this idea of technology development is not something that works top down, but that's sort of distributed, lateral, vertical. That's sort of the link to the theory of Jeremy Rifkin about the Third Industrial Revolution. And the other thing that came back, which sort of relates to the first clip we saw by Dale Dougherty, this idea of personal expression in technology, not asking why, but just doing it. I think it's interesting that Neil Gershenfeld here adds a third point, maybe saying that this technological shift could be an instrument of empowerment in developing countries, and an instrument to solve problems in developing countries in a different way. We might want to come back to that at the end in the discussion. So back to my timeline and the year 2005, which sort of could be a year zero for making movement. Obviously there were things happening before, like the first Fab Labs were set up in 2002, 2003. There was a hacker movement that sort of started earlier, but as of 2005, those two lines, the Make thing with the Make magazine and the Make fairs, sort of festivals where makers come together and show their funny bikes and small things and many other things. Make developed into a whole universe of things. The magazine, the Make Fair, there's an online shop. There's the idea that learning should be incorporated in making, or vice versa, making should be incorporated into learning. And with the Fab Labs, Neil Gershenfeld, in analogy to Moore's Law, plotted the number of Fab Labs, fabrication laboratories globally, from starting somewhere in the early 2000s with a couple of labs to over 1,200 labs globally, and sort of argues that like computing power increased exponentially, so does fabrication power increase exponentially. Just as a side note, of course, making is not something that started in 2005. Society has been made around making things earlier, and a colleague of mine, Paul Atkinson, noticed that the emergence of do-it-yourself as a necessity for many is lost in the mists of time, but defined as a leisure pursuit, a pastime. It emerged from a perceived need to keep idle hands busy. In the hours following a long working day, it acted only to bring the Victorian work ethic from the factory into the home. And there were probably a lot more than those couple of
government and societal programs that try to actively include making into societal and economic development. So in Turkey, there was something called village institutes. And village institutes were supposed to be learning environments for farmers in Turkey in the 1930s, 1940s. Part political indoctrination, part trying to separate farmers from industrial labor, part educational. And in the UK in the 1980s was something called technology networks down in London. The Greater London Council set them up, and they were sort of set up as an environment for socially useful production. That was obviously the time when a lot of factories got shut down. And interesting, Adrian Smith, who researched those technology networks, knows that recalling the radical roots and conflicted experiences of the workshops brings to the fore issues still relevant today. Tensions between prototyping activities for business development as distinct from more critical technology agitprop for political mobilization. Working at equitable relations between codified formal expertise versus tacit experiential skills, and the influences of broader political and economic changes and wider movements for alternatives. Those dilemmas, I feel we still got in this free belief that it started in 2005 and it's relatively young maker movement, which some call a social movement. Now, briefly, I want to sketch what developments in the economy, in society, are somewhat related to the maker movement before going into cases. Obviously, we talk a lot about the circular economy and how important that is for the planet. A colleague of mine in Helsinki has studied the relation of the maker movement to the circular economy, and she found that, yes, there is a lot of aspiration to turn maker spaces and fab labs circular, to turn personal fabrication circular, but it often remains aspiration, because materials that are used are often plastics, are ABS, are stuff that's not exactly circular. Bio-based, sort of related to the maker movement. There is a sort of sideline, which I'm not going into tonight. There is a sideline of the maker movement that is actually focusing on providing public biolabs where anybody and everybody could walk in and experiment with living organisms, and often they start with mushrooms. But as we all know, there are tools like CRISPR sort of available, so that's rather uncharted territory, and very interesting to.
How about bubonic plague?
Yeah. So, I mean, as long as it's around you know, growing mushrooms and brewing beer, it's probably fine. But sort of the borders are somewhat diffused there. There has been a lot of talk about the sharing economy, and certainly those makerspaces and fab labs, I would argue, are part of the sharing economy, as people sort of share the tools of manufacturing. And I'm going to come back to that at a later stage in the talk. This idea of the as-service economy. We're not supposed to own stuff anymore. We're supposed to lease stuff. Car dealers have been very good at that. Makers of dishwashers and washing machines think that this could be an excellent business model for them as well. Often sort of saying this as a service economy would extend the lifespan of products. Kind of skeptical if that really is true. And you might have heard of the donut economy. Kate Rayward of Oxford talks about that. She's sort of saying we need different ways to think about the economy, and the picture she uses in the book, which I brought along, the picture she uses is a picture of a donut, where she's going, the outer circle is sort of the outer border of the donut is the planetary boundaries, the resources of the planet that we've got, and we shouldn't overshoot there. And in the boundaries is something like equal rights and social justice, and we shouldn't go beneath that boundary. So the economy should remain in that donut-shaped thing. Again, a lot of aspiration, a lot of talk in the maker movement that yes, it should be accessible for everybody. Again, I've got some doubts there that the maker movement would do justice to strong donut philosophy. But let's look into a few cases. And as I said, the signature machine of the maker movement of the third industrial revolution is the 3D printer. So I thought I would start with the 3D printer, with a very famous and impactful type of 3D printer. This one has been developed by Adrian Boyer at the University of Bath. And his idea was, I want to make a machine that can reproduce itself. So in essence, this is the parent machine and this is the child machine. And obviously, through the intervention of humans, this machine was able to sort of build that machine. Because in terms of engineering, he uses a lot of standard components that you could get at any hardware dealer. And the more intricate parts that bind things together can be printed with that 3D printer. So that was the original idea. The RepRap got published in 2005. And what I've got here, you can't read it. It's not supposed to be read. That's where the first RepRap started. And that's sort of the genealogy, the family tree of all kinds of 3D printers that were developed between 2005 and 2012, going back to the original schematics and software of the RepRap. Why could this happen? Because Adrian Boyer decided to make all those things open source. And I've just shown you a little part of that family tree of the RepRap. So these are typical RepRap sort of home-built garage-type 3D printers. But out of this family came two companies that are still producing 3D printers. Initially, obviously their idea was that they would produce 3D printers for people to use at home. You remember like 5, 6, 7 years ago, everyone was talking that, in 4 year times, well, are we all going to have 3D printers at home? We're not going to buy any stuff anymore, which obviously didn't happen. But these two companies are still producing 3D printers. MakerBot started in something like 2009. Yes, we can see it there. MakerBot started in 2009 in a hackerspace in New York. They started to set up a company Initially, everything open source, you know, sort of kind of, we followed this ideology, we belonged to that open source family. Until in 2011, they got venture capital funding, which forced them to stop being open source, obviously. And in 2013, the company was sold to one of the big players in 3D printing, to Stratasys, for over $400 million US. Ultimaker is still independent. They started in late 2010. And that's one of their machines. That's the latest generation Ultimaker 3. They're still putting all their stuff that they produce out there into open source repositories. So if I switch over to that. If I go to GitHub and I go to search for BOM for bill of materials in this organization, I can find the bill of materials and parts for Ultimaker 2. Not yet for their latest machine, because that's the way they operate in open source. They say, okay, once we're far enough developing the next generation of machines, then we put the other versions open source. And they're still working. Yep, there you go. They're working with their own platform where owners of those machines can share visions they develop. So let me search here. So if I search in that repository for Ultimaker 2, then here you see I get different knobs, I get additional doors, I get additional frames, I get holders for tools, fan mounts for the nozzle, stuff that people who use the machine in some sort of, personal fabrication developed to improve the machine and share it with others. This idea of building a community around 3D printing, or another example, a company called First Build, they were set up by GE and a couple of universities, Tech Shop, and so on, with the idea we want to attract people to innovate on household white goods, such as ovens, washing machines, dishwashers, cookers. And in this short clip, they're going to explain how that.
Welcome to.
Recently spoke to a former member of First Build. He was there, one of the managers of the machine shop, and he quit. He didn't quit because he didn't find it a nice place to work. He didn't quit because he didn't find it was innovative. He quit because the microfactory was not geared up to produce all the products that they sold. So they ended up, instead of innovating, they ended up manufacturing the same thing over and over again. Because they probably didn't think through the whole logistics, supply chain, and manufacturing assembly that is required to set up such a thing. So there is another company which I would like to show you. They're actually from London, Open Desk. they're essentially designing and building office furniture. And they're quite successful to sell that office furniture to incubators and accelerators and startups. But the way they do it is different because, in essence, they draw that furniture digitally. They assemble a prototype and test it, and then again they put the files for cutting the furniture, the parts of the furniture. They put them online, and they feed them into an ecosystem of furniture makers that use computer-controlled machines to cut pieces and assemble the furniture. So they really thought about the whole distribution network. And in essence, you can get open desk furniture almost everywhere on the planet made by local makers. Or if you wish, and you would have a CNC mill at home, you could obviously do it yourselves. A last example, which just came out this year, you all know Bang & Olufsen. They came up with a funny idea to sort of extend the lifespan of older audio equipment, particularly speakers, because obviously they're moving from wired systems to wireless systems. But they want their clients to certainly keep the speakers and just buy the amplifiers. So they came up with a kit to sort of retrofit old speakers and connect them to the wireless systems. But the interesting part about this wireless kit is that they made it totally open source. So again, with the idea that audiophiles, enthusiasts, could sort of start to co-develop things on that platform. So what about value creation in the business models? Over a number of years, starting in 2014, I did a study on people who started out as hobbyists of 3D printing and moved into more serious business. How did we do that? There's a platform called Thingiverse, like universe for things, Thingiverse. Pretty similar to the Imagine page that I showed you with Ultimaker. It's a website where people can upload their free designs. Say, I've designed this little herd that you could 3D print and assemble yourself. I want to share that with the world to see how people react and if people actually take it up and use it or change it or modify it or want to interact with the platform. So we looked at data from that platform Thingiverse and selected the top 60 contributors that had the most interactions with others. And then we were looking at that, and we ended up with a first sample of 60 people. We then were looking, do they have like company websites or web shops or something like that, which reduced the number to 25. And we found sort of 5 types of what we thought that would be the business models that they have, from online brokerage platforms to web shops to printer retail, prototyping, and research and education. So we selected 3 companies from each of these categories, which led us to 15 people who we contacted. 8 of them agreed to take part in the interviews, and we asked them, would you know anybody else that we should include? That was the snowballing, added 3 other contacts. So we ended up with 11 companies who we interviewed in detail. So you know, we started off with those kind of 5 salient business models that we thought that are the typical business models that those people would use. You know, brokerage platform saying, hello, I can 3D print anything you want, send me your file, I'm going to do that. Others having a web shop, so, you know, selling jewelry or selling fan objects or selling useful tools. Another group who actually started to sell actual 3D printers, people who were doing prototyping, and people who were doing research and education. And you see, when you add these numbers, that's more than 11. And that's one of the most important findings of this study. In business, one assumes that the business typically starts with one single product as the business model. And that's how startups typically work. And this was obviously not the case here. There could be different explanations for that. This could be actually unique to these types of business. It could also be that each single business model for itself wouldn't pay enough to sustain the business. So we didn't really find that out. But what we found out that when we reviewed those companies 3 years later, that 6 of the 11 were still in operation. 4 of them were wound up, and for one it wasn't clear what happened to them. And one of them actually added another field to their business activities. So what does that tell us about the self-production economy? So I've been starting off with 3D printing, so I'll continue or revert to 3D printing. You probably have all heard of the Gartner hype cycle. Yes? Do I need to go a little bit into detail? So Gartner is a global consultancy, mainly in technology, and looking at how various technologies developed, they found that typically there is some kind of technology trigger, and then expectations rise. There's what they call the peak of inflated expectations. Then people find out, oh, it's not so easy, or it doesn't work like that. There's the trough of disillusionment, and as technology matures, they call it the slope of enlightenment, and then the technology enters the plateau of productivity. And they're plotting all sorts of technologies against this curve. So they also plotted 3D printing, and from 2008, they started to plot 3D printing against this curve, and until 2011, it stayed like just before the peak of inflated expectations. In 2012 and 13, they were going, yeah, this is now the peak, and they're always saying, and we expect the technology within 5 to 10 years to reach plateau of productivity. And then something funny happened in 2013. I guess Gartner started to understand that there's no such thing as 3D printing. So they took it apart into consumer 3D printing and enterprise 3D printing. And after that, the whole Gartner thing exploded in 2016, 17. They sort of divided 3D printing in 10 or 20 different branches. Until then, in 17, they sort of gave their predictions for 2018. Going, okay, 3D printing, commercial and military aircraft will fly with 3D printed engine, airframe, and other components. So this was a very specific sector that they believe will develop. 25% of surgeons will practice on 3D printed models of the patient prior to surgery. That's a real thing that's happening. The top 10 consumer good companies, 20% of them will use 3D printing to create custom products. 20% of enterprises will establish internal startups around 3D printing. 40% of manufacturing enterprises will establish 3D printing centers of excellence, and 3D printing will enable organizations to shift from designing for ideal manufacturing to manufacturing the ideal design. The very interesting thing in this whole list is that personal fabrication does not appear. So they completely left out what they have here with consumer 3D printing. So, I'm bringing back Neil Gershwin over here. He's giving his theory why this could be the case. Again, a number of things in there. The relevance, again, of this technology for developing countries. But I think the last bit is very interesting, where he claims that the maker movement at the moment, the makerspaces, the fab labs that we've got today, are an analogy to the PDPs we used to have. So this is a transition period, and probably that explains some of that paradox that we see the number of fab labs growing exponentially, but at the same time, statistics from the UK actually telling us that DIY, do-it-yourself, in the time from 2005 to 2014, it's barely visible here in this graph, but that's a decline of 20.5% in time spent in households on do-it-yourself and home improvement, these kind of things. So this is kind of a paradox, and you know, it could be that this exponential growth is more in education, or it's more seen as a recreational activity, and not in the same, doesn't appear in the do-it-yourself statistics of the British Household Panel Survey. But I still got a question mark there. Why could that be? And if we look at what's happening with those fab labs and makerspaces, or what we could call the self-production hubs, the place, the PDPs in self-production, so to speak. If we look at what's happening, some are really struggling to survive and are essentially drawing on voluntary work. Others close down to lack of funding, like I guess Make Aberdeen had to shut down because they run out of money. Even one of the biggest chains of makerspaces in the US, Texas, which was set up with a massive ambition. These were 200,000 square feet facilities where you pay between $100 and $150 per month to be a member. They went into bankruptcy earlier this year. China started a massive state-sponsored program of makerspaces a couple of years ago, but they're looking at dwindling numbers of people actually coming to those makerspaces and inventing new stuff. On the other hand, some educational spaces at universities, libraries, museums are doing extremely well. And in large urban areas, like in London, like in Paris, like in Barcelona, they appear to be a good breeding ground for these kind of self-production hubs. But the question there is really, is that this massive development of self-production becoming a new essential factor in the economy? Because what we're seeing, and that's this book, Masters of Craft, all jobs in the new urban economy. In this book, there are four case studies entitled "The Cocktail Renaissance," "Distilling Authenticity." We've all seen those new brands of gin exploding over the last couple of years. It's this kind of thing. Working on Men. We've all seen those sort of hipster barbershops appearing. I don't know whether they exist in Aberdeen. Yes, they do. And show the animal sort of new types of craft butchers. But again, the question remains really: has that the potential to really become a substantial, significant part of the economy, or is it like this book finishes here with the example of Giancarlo's successful path from going to college to managing a medical center, to becoming a novice butcher in New York City, to finally become the head butcher at an elite whole animal shop. It's a dream for many people in this book, and younger aspirants in these industries. Many, like him, get to live in it. But it's a very, very, very niche thing, basically, for a niche clientele and for a niche number of people. What's going on? Or